Hello there, my name is David Cater. In this video we're going to take a look at power factor with the circuit that we did in the previous video, which is an RL circuit in AC. Alright, so power factor is a relationship between two components in that circuit. Okay, so the power factor is the power over the apparent power. So the relationship between these two sides of the triangle. Alright, so what does that mean? It gives you an idea as to how much power and reactive power is in the circuit. Alright, so if we go ahead and we calculate this, we can get a good idea as to what the power factor of this circuit is. All right, so it's just as simple as taking the watts, 158.15 watts, and divide that by the VA of 337.454 VA. Okay, so when you do that, it yields you a decimal. It's going to be anywhere between 0 and 1. Anything in between there. All right, so it can never be greater than 1 because it's really like a percentage. How much of this is actually power in terms of watts, and how much VA is there in the system? All right, so when we go ahead and calculate that, we can see that we have a lot of V's in this system, so we have a very low power factor of 0.469. All right, so that's very, very low. A lot of circuits like to be up to around 0.8 or 0.9, approaching a power factor of 1. So this is a very inductive circuit. It's not a bad thing, it's just what it is, all right? So that is the relationship, and that's the angle right in here. So if you were to do the cos of the angle, the cos of theta here, if this is our theta, it will get you the exact same number of 0.469. So the power factor is the adjacent over the hypotenuse. So that really is kind of what the function is. It's the cosine of that theta, and it just happens to be the power over the apparent power. All right, so it's just another way to do it. If you already have the angle, you can just punch it in the cos of theta, and they will get the power factor. All right, so there's one more thing I want to draw your attention to, and that is, in the previous video, we took this impedance triangle, and we multiplied each side by I squared, and that's how we got our power triangle. Well, if that's the case, then these two triangles are the exact same shape. We multiplied each side by the same value, so it couldn't really change shape. It may have gotten bigger, but it didn't change its shape overall. So that means that this angle here, this angle theta, is the same as this angle. All right, so you can also make the statement that the power factor is not just only the power over the apparent power, but it's also the resistance over the impedance. Be very easy to make that jump because the shapes of the triangles are the same, and so if you have these two values, then you can go ahead and get your power factor the same way, R divided by Z, and that's exactly what you're able to do. All right, so power factor, it is just a relationship between the two sides, and it gives you an inclination as to how many watts are in the system versus how many VARs are in the system, and you compare that to the VA, which is the total of the two. All right, so thank you for watching, and we'll see you in the next video.